Hello, welcome to part 3 of the intro lectures to Unity. I say 3 or 4 because after watching the previous hour-long follow-along rollerball video, you should head off and look at the parent-child relationships video and the video on prefabs. Normally in this part of the lecture, I begin with prefabs, but no, it's elsewhere. Go watch that one, and then come back here. And we will continue on after that with more smaller topics to put together. So we got our little project. We've got our ball that rolls around. Whoa, it flies off because I have some software open that's pretending to be a gamepad. I also have a mouse in my walls and I can hear it. And we have that camera follow script, right? Our first sort of real script we added. So we have some ability to make some things, to make some games, but we're still missing a lot of fundamental features, and that's what this video is going to be about. Some of these fundamental ways that Unity sets up its behaviors and its scripts and things. So let's get started with that. Again, first, prefabs. Second, parent-child relationships in the hierarchy. Other videos linked or around me in this page somewhere. Go watch those. Come back, welcome back, hello. Game objects, right? We got scenes, game objects, components, assets, and then properties as our sort of main pillars of Unity. We've got game objects. Let's take a look at this little window up in the top of our inspector. These are game object settings. These are settings that exist even on empty game objects. They have the transform and the transform settings, which are its position, rotation, scale, and parent-child relationships, all stored in the transform. And then this other stuff. And this information is really useful and very important. So let's go through it. First and foremost, the game object's name. Player, banana, whatever we want to call it. We can rename it, right? Typing. We can rename it right from the top. We can also rename it from the hierarchy, and with F2 is the keyboard shortcut to rename things. There we go. That's your text box. It renames it. Hey, easy. There we go. Naming game objects is kind of a thing. We should definitely name our game objects. Floor 1, 2, 3. That's silly, terrible names. I believe we were working on putting all of them as a child object, which makes it less of a problem to rename them, but so multiple game objects can have the same name, right? I can have 2 game objects with the name player. The name is not forced to be unique. And that's important to know when we get into coding, because we never want to use names as something that controls our code, right? So names are just for you to look at, reference, and understand, not for computer code. Okay. Names are simple enough. Next is this little checkbox next to the name that is an active or deactivated game object. If it is unchecked, it is deactivated, which means none of its components will do anything. Its components, they can still exist. They can still receive function calls. If something else that is activated says, hey, call a function, they can still receive that and then do something about it. They are still in the game's memory. They're grayed out here, but they're in the game's memory. But they won't receive event functions, and a lot of the other Unity functions, like get component in children, I believe, or find game object of type, will only search for active game objects. So if it's been deactivated, it sort of hides it from a lot of the Unity features, which is really nice to have. You can, you can have things like, I don't know, spike traps that appear, or when the player dies, they get deactivated instead of destroyed, or and then they can still like play sound effects or something. I don't know, but there's a billion and one reasons to use active and inactive game objects, object pools, right? Take advantage of that, the fact that they're in memory, all sorts of stuff. Yeah, so active and names, and then next is static. This is actually a number of different settings that are all the word static. Contribute to global illumination, occlusion, batching, occluity, and reflection probe all have to do with the rendering system and how Unity's visual system works. Navigation static and off-mesh link generation have to do with the nav mesh system built into Unity to do pathfinding, which is another feature that is hard to do yourself that Unity has built into it. For the most part, if you're not using pathfinding, and if you don't know what that means, then you're not, this is a visuals thing, right? We should check this if the object doesn't move in order to tell Unity to do some optimizations to allow the game to look better. So we can select all of our ground things. We can say, you are static, you are not moving. And then we can grab all of our cubes here. Hello. I had a real hard time with that. Collect all of our cubes, make them static. Those aren't moving, those are just little obstacles. And now Unity can do something about that. And something that it would do about that is baking environmental light maps, which are a whole thing that are not in the scope of this video. But if I click generate lighting and then wait a little bit for this progress bar that my window is blocking, after a little bit my game will just look better. The shadows will be a little bit more detailed. It'll be like contact shadows, but only between things that don't move. Hey, there we go. I have like 7 minutes remaining on this process, right? I can, hold on, where's my, there it is. It's going. So we want to not bother with that. Let's cancel it. Great. I'm moving down. Hello. Okay. So subject for another video, space for another time. Space for another time. That's not English. We'll learn about it later. It's not something we need to worry about now. So being static is mostly a visuals thing, right? It tells Unity that you're not moving. There are some other things that use static a little bit. One of them is rigid body, but it has its own setting for static. The 2D rigid body has its own setting for static. 3D doesn't. It's kinematic. For rigid body elements that don't move. Sorry, I was thinking 2D. 2D has a dynamic kinematic, which subject for another video, or static, which says, hey, this exists but doesn't move. So that's another thing that you can kind of ignore for now, but once we start learning about how to make our silly little games look good, which pretty soon we kind of care about that, we'll be talking about static more. Okay, next, tags and layers. Tags and layers are just a single property that the game can have. So there's a drop-down list, we can choose one tag, drop-down list, we can choose one layer. That's all they are. The difference between tags and layers is that Unity uses layers in some of its systems by default. Its physics system uses layers, its rendering system uses layers. So I could give maybe this screen section a different layer, like water, sure, why not? And then I can go to my main camera and tell it to, in the culling mask section, to maybe just don't render water, right? There it is, it exists, it still looks the same, but if I were to go and fly off, that section of the ground would be gone. It's still, the player would still collide with it, they'd still hit it and all that stuff, but the camera is not displaying it. We probably do want to display water, and we probably don't want that one floor section to be water. We'll put that back to default. So the rendering system can use layers to determine what to display and what not to display for cameras. And then the physics system can use layers. If we go into our, maybe it's the first time we've done this, into our project settings, into our physics manager, and scroll all the way to the bottom, we get this, this matrix, this grid. And this grid is just, it's all the layers on the left, it's all the layers on the top, and then this checkbox is sort of a connection between two layers, right? And the question that this checkbox is the answer to is, will these two layers collide in the physics system? So let's say water and default doesn't collide, right? Water and default doesn't collide. And then we were to make maybe this floor section here water, but the player would be default. Well, if I hit play, the player's going to go through the floor because those two layers don't collide anymore. So being able to control your physics layers and your collisions is important to fix lots of physics bugs and as well as optimize your code so you're not checking for collisions with things you don't need to check for. Often the player might shoot bullets that spawn from inside of them and they don't want to hit their own bullets so they go through them, things like that. Cool. So layers also can be turned on and off in the inspector in the Unity user interface here. So I could turn off the water layer and that one disappears and turn it back on. It's still there, it just is hard for me to mess with. I can also make it so that I cannot select objects. This is so huge, right? Especially for user interfaces. When you're working in UI, you often don't want to work on the game, and being able to go in and say, can we just not look at that right now? All right, it's still going to be in the game, it still exists, right? But that's just for me in the editor, can I just like not worry about it, right? So game still renders, but it's in the way. Can we just hide? Very useful to clean up the editor. Back in the day, Unity developers use layers for that kind of editor workflow thing all the time, and that got in the way because we also use layers for like actual game mechanics. So you'd have like 4 different environment layers, and then you'd treat them all the same in the game's code, but you would use them to turn on and off different elements, and that wasn't great. More recent versions of Unity added those same hide and don't select functionality to the hierarchy in our scene. And that's super useful. So a lot of the developers I know have started using that instead of excessive layers, because having excessive layers is kind of annoying. So tags, on the other hand, aren't like layers. They are exactly like layers. They're just this property that a game object can have. It can just belong to some tag. But Unity, by default, doesn't do much with it. It uses the main camera tag. I think it actually doesn't use that anymore. It uses the main camera tag on the main camera by default. I think it comes with a player tag, but I don't think there aren't many systems that are built into Unity or Unity default components that really heavily rely on tags, right? So that's fine. So that means we can use them for our nefarious purposes, right? Without worrying about breaking the physics system, which is important. So that's the main advantage to tags. Okay, the last feature of the Unity hierarchy window is super important. You will also maybe almost never use it. It is this little icon here, which allows you to change your scene gizmo, your scene icon for your Unity element. So this one is a mesh renderer, so my object will show up in the scene as a mesh. But if I have an empty game object and I want to click on it, I have to click on it here. You can kind of see there it is. I can give it an icon, like a little blue diamond or circle or the label with its name, node, and then it will just be there in the scene view, even though it's invisible, and I can click on it. Very useful. So when you have things that don't have visual meshes but are still using their position in space, I say node as an example for like a pathfinding system perhaps, being able to tag and label those and select them in space, very useful. You can also choose icons from a sprite, and you can import your own images, and lots of Unity developers go sort of out of their way to, to pretty up their editor, their gizmo experience with all sorts of fun icons that are very easy to see. You see that a lot in asset store purchases, which is excellent and good, but developers who are just working on their own, we don't care so much. I won't speak for everybody. If you want to spend a lot of time making custom icons for all your stuff, you go for it. Okay, so we covered prefabs in a different video, and we covered the tags and layer systems. Let's start making an actual thing in the project. So we are going to make a system that is going to spawn in randomly a bunch of coins that our player will be able to collect. So in order to do that, we're going to need a coin prefab, and we're going to need a spawner system. So let's start with the spawner system, since that's the new information here. First, we're going to make an empty game object that's going to be our coin spawner. And now we're going to need a, we can give it a little, let's give it a little orange tag here, our coin spawner. And now we need a script that will add to it. Normally you would right click in the Unity editor window and make a C# script, coin spawner, uppercase, all the words, no spaces. But I want to show you a different way to create scripts and to show you a sort of gotcha that happens pretty often once my Unity editor updates. So if I add a component and I start searching for what I want, like follow target or player movement, I can't type today, player movement, this list will populate. I'm kind of covering the bottom of it, but this list will populate with all the different options that we have. If I start typing the name like coin spawner, and there isn't a coin, there isn't a script, I do have one option available, which is this new script option. And I click that, and it will recommend a name for me. If I didn't name this, if I put a space here, coin spawner, and said new script, it would give me a little error that says, hey, don't do spaces. And it would remind me of that, but it wouldn't get in my way. It would let me make this scripting correctly. Create and add. That's going to make the script and add it to the game object, and it's going to save it right in the root directory of my project. And I can open that, which will open Rider in the background. This is kind of a problem, because I might be going through my code, and I might have this open in a text editor, like Rider. So my coin spawner script here has been opened. But later I go, I need to move that. I need to put it in the scripts folder where it belongs. And then I go back to Rider. Now, Rider is a pretty smart IDE, and one of its features is it noticed that it moved, and then it noticed that the file I was editing doesn't exist anymore, and it just closed it. And that was to solve exactly the problem that I was about to demonstrate. So let me show you what this looks like in VS Code, right? So if I open this script in a different, oh my God, I have to choose. Sorry, I'm on like a different screen. VS Code, okay. I've changed the scaling for this video recording, and now all my UI is messed up. If I open it in a different script, I go back to Unity. Sorry, I open the text file up. I go to Unity, I move it. I've basically created it here and destroyed it in that other place. If I'm here, I get this little red thing that doesn't exist, but I'm not paying attention. I'm typing this code, blah, blah. I hit save, right? I just hit Control S. Now it does exist. I saved it back here, and it just made it again. And I can see I have an error that I already have a definition for coin spawner, and that definition already has a method called start, and it already has a method called update. And it's like, well, yeah, because now there's two scripts with that name. And I want to delete one, and I don't remember which one I want to delete, and I didn't close it, and life is hard, and one of the reasons I like Rider, you just kind of don't have that problem anymore. It just closes it for you. But it's just something to be aware of. You want to move the files around via Unity, and then make sure we are opening and editing the correct file and not opening a ghost file that if we save will get recreated, and then now we have two of them. It happens all the time. I know I just spent a long time talking about like a very niche error to make, but it happens all the time. Okay, coin spawner. Coin spawner, how do we spawn a coin? Well, the first thing I like to do is outline my code with comments. If I'm a little bit unsure about how all the different pieces are going to go together, I like to break it down into the parts and then write out the parts that at least I do know how they go. Spawn coins on start is probably what we'll do. Let's get rid of update. We don't need it. Okay, well, let's just, I don't know, let's write a little spawn function. We can shove our code there, because if I want to move it out of start, I should be able to do that pretty easily. So I should keep my code kind of contained in functions that are well named and describe what they do. So this will create one coin. let's rename it. Hey, a writer feature, Shift F6, on coin, and now it renamed both. Oh, so good. Okay, so we will create one coin, create a coin. To create a coin, we need to know a couple of things. We need to know what game object to clone. We need to know where to create it. We need to know how to orient it. Because we're going to use a function to do this called Instantiate. And this function takes a number of different versions of it. One of the versions that it takes is an object to clone, a position, and an orientation. It says rotation. I'm going to be very pedantic with my word choice. This is an orientation, which is a rotation away from a known position. Okay. It's sort of like position and movement difference, right? And we define our position as a movement difference away from the world origin. It's like that, but with rotations. Okay. So I need an object to clone. Well, let's just use a public property to store a reference to some game object. And then we'll assign that game object to be the cloned object, and it will just be what it is. So we're going to make a public game object, and we're going to call it coin. So now whatever this variable is going to be equal to is going to be the thing that I want to clone. So we'll go back here and we'll instantiate the coin. So I have taken this problem, what game object to clone, and I have kicked it into the Unity editor. And now the Unity editor, I have a little slot to edit where I can deal with the problem here. Turns out it's a lot easier for me to deal with this reference, this problem in Unity than it is for me to deal with that via code. So, solved that one. We need to know where to create it and how to orient it. Well, we can do that same kind of thinking of like, I don't know where I want to create a coin. I don't want them all to be created in the same location. So why don't I let somebody else decide where to spawn the coin, and I'll just create it there. So this function will now receive a value that tells it where to create the coin, and it will create the coin, and it'll create it at that location. The last argument we need in this function call is how to orient the coin. And we're going to just type this Quaternion.identity. Okay. Quaternions, I don't have time to explain what Quaternions are, but I can explain why we use them. Okay, I'll explain a little bit what Quaternions are. They are a four unit variable. So they have an x, a y, a z, and a w. These are just numbers, just floats. And we use these numbers to define a rotation. That's it. That's a quaternion. Quat for 4. We use 4 numbers to define a rotation in 3D space. We use them because using what we call Euler angles, E-U-L-E-R angles, this x angles around each axis like we edit in the inspector, these angles have a problem called the gimbal lock, where we can rotate one axis in line with the other axis, and then how we rotate them, it messes it all up, and everything is terrible. There's also some interpolation reasons to use them, and they're very fast and efficient, and computers are good at them. Programming is this compromise between computers and humans. Quaternions are difficult for me as a human to visualize and write, because they're 4-dimensional objects. But computers are very good at them, so we make that affordance to computers to use quaternions. I said they're 4-dimensional objects. I don't want to leave that statement hanging. If you think of one rotation of a 2-dimensional object just rotating in one plane, and you think of like a unit circle, if you just have a position on that circle as defining a rotation, like around the circle, the xy coordinates of that unit circle would be a 2-dimensional number, an x and a y coordinate system, and they could define one rotation, right? So we can use a circle, a 2D object, to define one axis of rotation. Well, we can use a 4D circle, which I can't visualize, and I definitely can't draw on a computer screen that's flat, to a coordinate on that 4D object to represent rotations in 3D dimensions. So they're hard to visualize because of that reason. They're not super crazy on the math, but you just like, if you wanted to edit their x, y, z values or w, it would be annoying. And that's quaternions. Okay. Gosh, what did I do? There we go. Identity is the identity function for rotations, which is a not rotated rotation. It is a default orientation. So the identity property of the addition operation is 0. Anything plus 0 is itself. The identity value for multiplication is 1. Anything times 1 is itself. And the identity value for rotation is stored in this placeholder variable that I can access by typing quaternion.identity, and anything rotated by that amount will be the same rotation. Okay, that's more about quaternions than you ever need to know. That's not true, you'll learn about them later, but that's the topic for another video somewhere else. We'll worry about them later. I just hate how everyone hand waves them away and says don't worry about it. Like, you should worry about it. They're not that crazy complicated, they're just annoying. But luckily we have lots of fun functions like Euler angles, where I can, I could have typed the values I directly want, just like in the inspector, which uses these Eulers. And I could have just used this, and this gives me the quaternion form of that, right? There's lots of functions that make working with quaternions very easy. You don't really need to directly edit their x, y, z, w values. Whew, okay, I'm not going to say the word quaternion again for the rest of this lecture. You're welcome. We created a coin. We don't know where to create it, but we let somebody else deal with that. We do know how to orient it, the default orientation, so we're just going to leave that as is. There we go. We are now instantiating a coin. I'm getting an error here because I am not spawning coins at any appropriate location. I need to tell it where. Well, I took that problem, I gave it to someone else, but it's still me who has to solve it. Let's just type in a new vector3 of 0, 0, 0, and the shorthand to type that is vector3 dot 0. Shorthand for writing vector3 0, 0, 0. Very good. And that will just spawn one coin at world origin when this start function is called. And we're going to talk about those event functions in this video, so stay tuned. I'm going to go over that. So now we just need to make a coin object. I'm going to make a cylinder, call it coin, and we're going to make it nice and flat. There it is. And we're going to make a material for it. Call it coin, make it yellow, make it shiny, and give it to the coin. Not super shiny, a little bit off. Okay. There's our coin. Beautiful, right? Our collider shape is not updated. It uses a capsule collider, which uses a point and a radius to do the end caps. Hold on, the height is being stored here. It uses a point and a radius to do the end caps, so it's not a perfect representation of a cylinder, but it is much more performant. So the physics shape doesn't match perfectly. That's fine, we don't care. And that's our coin. So let's turn that into a prefab. You know how to do this, but we want to remember, we want to stay organized. For small project, organizing by file type is a perfectly fine way to stay organized. And we drag our coin into our prefab thing. So that I don't get confused, I'm going to delete the coin out of the inspector. Now when I go to my coin spawner and I want to give it a coin, I don't accidentally give it the coin in the scene that I clone. Instead, I give it my prefab reference and say, hey, clone that thing, that description of a game object, clone that one. And it accepts that just fine. So now there are no coins in my scene, but when I hit play, that spawn function should get called, and we should spawn a coin. And it got spawned at position 0, 0, 0 with the rotation 0, 0, 0, and there it is. Beautiful. All right. Now, I want my coin, I want to fix up my coin. I want it to be a little bit like that, and I want it to be rotated vertically. But if I do that, when I spawn the coin, it'll get rotated flat. Now, we could solve this. We could have our spawn code actually take the existing coin's rotation and just spawn it at the value we set it to. But I don't want to do that. Not because it isn't a good solution, it's a fine solution, but I don't want to do that because I want to demonstrate some prefab editing trouble, right? So the way to, and I want to talk about parents and children and how we might actually use them to solve our problems. It's generally a good idea to have a parent and have a child be the thing that's rotated. And have the parent not be rotated when we're dealing with meshes that by default should be upright. If I think of the coin in my head as an upright thing, its 0 rotation should be its default rotation. If you do that, you're going to have less pain and suffering in your life as a Unity developer. So we're going to use a child and parent relationship to solve this problem for us. I just demonstrated it here, but let's do it in the prefab. Now, if I make an empty object, I can't set it. You see my cursor goes to a little warning symbol. I can't set it to be the coin. So what I actually need to do is duplicate the coin. I'm going to call the child object coin visuals, and then I'm going to call the parent object coin, and it will be scale 1, 1, 1, and the child object will be scaled down. Parent object will be 0, 0, 0, 0, 0, 0, 1, 1, 1. Here's my object. Oops. Okay, sorry, it is scaled down, but I have the visuals on the parent, so I just need to remove those. So now the parent is empty, and its rotation is 0, and its scale is 0, which is great. And my coin is empty. It's not like off in Canada, so if I rotate it, it's going to like spin around in a big circular shape, right? The child object is at the same position as the parent, so if I rotate the parent, the child object stays the same. And then I can rotate the child object to be upright. It needs 90 in one of those two axes. All right. So I have coin, parent, and coin, and that's my prefab. So why did I demonstrate this annoying thing to do? Well, because you have to do those annoying concerns all the time, and messing up parent-children and having a child be like offset from the parent is a very common pain in Unity. So if we go back to Unity, we will spawn a coin, and we spawn it upright at the origin of the world. Great. What if I don't want to spawn it at the origin of the world? What if I want to spawn it at the position of the spawner? Well, to get the position of the spawner, I need access to its transform component, which by all mono behaviors, all components have default access to the transform component, and I can just grab its position property, which is the very vector3 property that we edit when we move it around. So now if I hit play, the coin should spawn right by coin spawner. There it is. Great. Amazing. I don't want one coin, I want many coins. And to spawn many coins, I need a loop. So we're going to write a loop. We're going to write, there are many different types of loops we could write in code, and the one that we are going to learn first is called the while loop. If you're following along, stop and just watch this one. We're going to delete this code in just a second and replace it with something better. But I like to demonstrate it. While is a keyword, right? You can't name your variables while because this word means something in programming, in C#. It is then a set of parentheses and a set of curly braces. So whenever the C# compiler sees sort of this set of symbols, it's like, I know what this is. And what it is a loop. So curly braces, like always, contain some other code and can be treated as like a single thing, right? Every time I say for this entire curly brace bracket to execute, it'll just do all the different things inside of it in order. And the loop is a conditional, just like an if statement. Just like an if statement, if this takes something true, And if it is true, it'll execute the code inside the curly braces. While the while loop will take something as true, and if it is true, it'll execute the code inside the curly braces. And when it gets to the bottom, it'll go back up and it'll ask the question again, and it'll repeat forever. If you just typed while true, you've created what we call in programming an infinite loop. Infinite loops are bad. So instead of creating a terrible infinite loop, let's create a loop that counts a number of times. So we're going to make a variable. Let's call it I, because I'm a programmer. And let's set it equal to 0. And then while, and we're going to give this a conditional. So that's one of these less than, greater than, or equal to symbols. And we'll say while it is less than the number 10, we will do whatever code knows our loop. And then I will set I equal to I plus 1. This is our while loop. So we create a variable. While this property is true, is 0, 0 less than 10. Yes, we run this code. I increases by 1. We get to the top. Is 1 less than 10? It is, we go. Is 2, is 3, is 4, is 5, is 6, is 7, is 8, is 9. Is 10 less than 10? No. And then we break out of the loop and we continue. So that is a while loop. Now, it turns out this programming pattern is really, really, really common. We see it all the time. So what we want to do is use the better version of this exact pattern, which takes, let's call this part A, let's call the conditional B, let's call the thing we run at the end of the function code C, and let's combine them in what we call a for loop. A for loop looks just like a while loop. It's got the parentheses and the semicolons, but inside of the parentheses are 3 parts. A, semicolon, B, semicolon, and C. We need to create a variable, a conditional that will happen once at the beginning. A will happen once at the beginning of the loop. B is a conditional that will be checked every time, and C is something that will happen at the end of every loop. So 99.99999% of times you use a for loop, you'll create a variable that you will call I. You will check while I is less than some number, and you will increase that number by 1. Let's delete that for loop and never look at it again. It's ugly and I hate it. And then let's move this code into here. I++ is shorthand for writing I equals I plus 1, which is, there's also another shorthand, which is the plus equals operator, which will do an increment to itself, give it a value. So if the value is 1, you can just do plus plus. If the value is not 1, you can do the plus equals, or you could just type out I equals I plus 1. All of these will increase the value of I by 1. I++ is easier to type, and we like it. And that's what you're going to see if you look at code online. So let's use that one so that we are becoming more familiar with these things. So we create a variable. Every single time we run through this loop, we go down, we increase I by 1, we check again. We go down, increasing I by 1, we check again, blah, 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 blah. Right? If we start at 0 and go until it's less than 10, we'll run 10 total times, which is what we want. So back in Unity, if I hit play, I should see my coin appear 10 times. Unfortunately, my coin has appeared in the same location 10 times. And that's not what I want. So I don't want to spawn it at my position. I need some new location. Let's start with a variable. And let's set it equal to our position, and let's shove the variable into the thing. Congratulations, I just didn't write any code. No, none of the behavior might changed. Instead of putting this directly into the function, I just saved it into a variable and then put the variable into the function. Cool. Okay, location equals, let's set it equal to location plus, or we could just do transform.position plus a new vector 3. Oh my God, what am I doing? What am I doing? I'm all over the place. I'm all over the place. Okay. We make our variable and we can set, all I did was the most annoying way to write a plus at the end of that previous line. If you're following along, you just got very confused. Stop and just realize all I did was add this thing to the end of it. We take our current position and we add some offset. I'm going to add the value I as the offset. So the first time this loop runs, I will be equal to 0. Our position will be our current position plus 0 on the x-axis. The second time it runs, it'll be plus 1. Third time it runs, it'll be plus 2, and so on and so on. So now instead of them being on top of each other, I should have a line of them. Ooh, very cool. And then I can do 2 times I. Have we gone over multiplication symbols? It's the asterisk symbol. It means times. I'll assume some familiarity with programming. You've probably seen that before. Asterisk is times. You don't type x. X is a letter we use for variables, so asterisk. And now they'll be spaced further apart. Neat. Okay, so that's instantiating. I'm going to leave it as an exercise to you to make a grid or even a cube of coins. And then the coins can, and you do that by taking a for loop and putting it inside of another for loop. And you'll hit a problem, which is that you can't use the variable I inside of where you're using the variable I. So you need to use a different variable name. And I recommend J. And if you're going to do 3 loops inside of each other, I recommend K, I, J, K. Let's move on though. Or pause it and do that exercise. Make the grid or square of cubes of coins. Okay. Now we can take our coin spawner. That's perfect in every way. And we can put it down here. And then when my game begins, I should have a big row of coins right there. Need to raise the coin spawner up a little bit. My changes didn't get saved in play mode, so jump back down. Needs to go up a little bit more. Okay. Now let's use a different value for its z position. Let's use a fun little function. Let's just type z and write it here, just so my text is really zoomed in for the video. You can just put this following code right in there. Let's use a function in the random class called range, and let's give it a value between -3, -5 and 3. Between -5 and 4, sure. And that'll return an integer because I gave it integers, so I need to give it floats so that it will return a float. Okay. Good thing I remembered that. Oh, I need to move that back. Go back here. So its x position is being determined by the by being 1 down the line, and its z position, the blue axis, x, y, z, RBG, remember? The blue axis is just being randomly set. And that's pretty cool. So let's take a look at that. Right? A little bit lower. I can't save in play mode. Pretty neat. Pretty neat. Ooh, you know what we could do? We could do like, if we wanted to randomly have the, coins rotated around the y-axis, we could give them a Euler angle of 0, and then for y-axis around the y-axis, we could do random.range between 0 and 360f. And then, that's kind of fun. I'm off script now. I'm just looking at my game. Look, they're all kind of randomly rotated. Yay, randomness. Give our game a little bit of variety and style. Where was I? Okay, back on script. The event system. It's time to talk about the event system. Okay, we're going to head to the Unity manual. And the help menu, Unity manual, which is going to open it up locally on your computer. So you don't need no stinking internet access. And I want you to search for event functions. Where is it? Order of execution of event function order. Where I had it and I clicked the wrong link. Order of execution for event functions. There it is. I'll put the link on this page below the video. Order of execution for event functions. There you go. If you search for event functions, it's like the page above it. This is an important graph. This is an important graph. So when we have a script in Unity, Unity will search through all of the different components, and it will look for functions that have a particular name, and it will add those functions to a list that it keeps track of, and it will call those functions for us, and that's how generally we make our code actually happen in Unity. We've already seen that start happens at the beginning of the game when I hit play. It actually happens when the game objects are created. So those coins are getting their own start functions run. Like if I spawn in those coins on a button press, like maybe a bullet or something, it would have its start function run. It's not being called at the scene load, it's being called for the objects being loaded, which for all these objects is the scene load. Okay. But there are other event functions we care about. We care about, where am I? We care about awake, which is just like start, but it happens before start. It's going to help you solve bugs. I tend to get all of my references in awake and then use those references in start, just in case I have like an order mismatch. We don't know what order these functions are going to get called in. I want you to, it's not random, but I want you to believe it's random because it is being optimized in ways that are beyond our immediate control. It doesn't simply just loop from top to bottom of a hierarchy, although it kind of does, but sometimes not. For reasons that are not in scope here. Unity just does what it does, right? So if one object has a start function and one object has a start function, we don't know which one's going to happen first. It's going to happen in the same frame, but we don't know which one's going to happen first. So we need to write our code in a way that if this function in my right hand that I'm holding up uses something in another function, and in order to use that other function, it needs like a different thing, like initialized or whatever, like a get component call, then we like to use awake to help us solve these bugs, right? So we like to get our references, our get components in awake, and we start our game logic in start, and then we just have less bugs and race conditions. So programmers out there, you've probably heard of race conditions. Awake helps us solve that. On enable will get called whenever the object is enabled. And on disable will get called whenever it's disabled. So that's nice. It happens in the frame loop. The frame, if it got enabled in the previous frame, at the beginning of the next frame, it'll have its on enable call ran. Reset editor thing. We don't worry about that right now. Then start. Then our physics loop. So we have another fixed update. Ooh, so our physics loop happens at its own update cycle. It happens at a fixed update cycle, which means it happens at a consistent time step. This makes physics not buggy, and it's important for Unity. I think it's something like 20 times a second or 5 times a second. There's a 2 in the decimal somewhere. 0.02 maybe, 0.2. I don't know, you can change it. It's probably in our physics settings. It's in here somewhere, isn't it? I don't know. Anyway, it happens at a fixed time step. So instead of the update loop, we can use the fixed update loop to get that time step. And if you're doing something like add force, you should probably do it in fixed update if you want your game to be a little bit less buggy. Next, animation stuff that we don't care about right now. Internal physics, the actual physics happening. IK animation stuff that we don't care about right now. And then things we do care about. On trigger enter, on trigger stay, on trigger exit. And then on collision enter, on collision stay, and on collision exit. So when physics events happens, when two things hit each other, and one of them is a rigid body, Unity will look through all the components on both of those game objects, and it will tell it, hey, if you have an on collision enter function, you just hit something, make that code happen. And that's great, we're gonna use that. Next is an on mouse event, which are input events, which I think Unity said they were once getting rid of, but I guess aren't. I don't know. I'm not gonna look that up right now. I tend not to use these. And then we get to update, which is our tried and true, happens every frame of our game, update. Yield is a coroutine thing, we'll worry about that one point in the future. A bunch of other stuff we don't care about, and then late update. Late update is just like a wake and start. Update and late update is there for you to fix your race conditions. Most often I've seen late update used for moving a camera, right? So if the player moves, and then the camera's following them, the player movement logic happens in their update script. And if the camera is getting updated, having its update function happen before the player, it won't move until the next frame. So it'll be like one frame behind the player. And you don't want that. You can probably feel that if your game starts getting kind of slow. So late update, we can move the camera after we know where the player will be rendered in the next frame. But before we do that actual rendering, we can move the camera and then do the rendering. So late update, useful for moving cameras and fixing bugs. And that's it. Nothing else. It's not true. You can all sorts of stuff. Use it for whatever you want. A bunch of rendering stuff. In my however many years of Unity development, I've used these all of 5 or 6 times. And all when doing custom graphic stuff. So not a thing you need to worry about right now, but they do exist. It's good to know. Unity editor things, coroutine things, on application pause for pausing. That's a different thing we not need to worry about. On application quit, nice to have. And finally, we get to decommissioning, which is destroying our game objects. Decommissioning. So when we get rid of a game object, it does not get destroyed immediately. It will be there until the end of the frame, which means we can reference it, right? If one update loop destroys a game object, but another update loop is still talking to that game object, it'll be fine until we get to the next update loop. So we don't care which, right, if we're worried about race conditions of destroying a game object, you don't need to worry about that because it won't be until the end of the frame. And the last thing that will get run is that game object will have an onDestroy function called. And that's a great time to do something like play a sound effect on a different game object and spawn a particle system in for blood splatter or whatever. We destroy you, and so on. And on disable, similarly, for disabling. Okay, so we've already been using start, we've already been using update in our player movement code. Let's go ahead and use on collision enter. Let's go back to player movement. So this is the code that's on the player movement. And let's use void on collision enter. Now, as I type, I'm going to get some autocompletes, and I'm going to see there's actually 6 of these functions. On collision enter, exit and stay. On collision enter 2D, exit 2D, and stay 2D. We are using the 3D physics engine. We want on collision enter 3D. If you're making a 2D game and you're using a and you're using a what did I name? Another thing player. And if you're using a rigid body, oh god, I'm hiding it. A rigid body or a rigid body 2D, and instead of a sphere collider, you have a circle collider, 2D, right? There's 2 completely separate physics engines. One of them operates in 3-dimensional space, one of them operates in 2-dimensional space. You can use both of them at the same time. Don't. That's silly. You can use 2D physics with 3D graphics. You can do like a 2.5D platformer game. It's very popular aesthetic. It's very nice. You can use 2D physics all you want. Unity doesn't care. It just has these 2 separate systems. Super, super, super common mistake is to use the 2D collision enter on the 3D physics system or vice versa. The 2D physics system and 2D physics components and then you type on collision enter, and this function never gets called. And you're like, my collisions aren't happening. What's wrong? Everything's broken. We want to use on collision enter. This takes an optional, you don't need it, takes an optional parameter called collision. And we're going to do a debug.log message, I hit something. I hit something. What did I hit? And we're going to see when does this debug.log statement get put into the console. Well, I hit something already. And then the player shot off because my silly 3D mouse is pretending to be a controller joystick and thinks the buttons are held down. But that's just a me problem. So it hit something when it hit the ground. But I don't just care that I hit something. I mean, I usually do care when. Usually when is like how we make our game logic happen, right? Player hit the finish line, enemy hit the player, bullet hit the enemy. We care about these things. But we also care about what we hit. So we're going to do a reference to, we're going to use this collision object. And collision is just a little bit of data describes a collision. So it's just a little object that has a bunch of properties that have, when Unity called this function, assigned these properties for us, they assigned it a collider that we hit. And that other.collider will be equal to the thing that we hit. Other.gameObject will be a reference to the game object that we hit. Other.transform, right? Other.impulse and relative velocity. We can get this data and do stuff with it. I made a mini golf game where the ball hit the wall, and I used the impulse, the magnitude of that vector, to change the volume of an audio source that played a bonk noise. So boop, boop, bonk, bonk. It's pretty nice. Other dot, I have all those properties in this just little bit of data that Unity gives me that describes the collision that happened. I'm going to use the GameObject property. I'm going to use the name string property of the GameObject property of the other collision variable that has been assigned here, right? Just like spawn coin has been given a position from somewhere else, player movement has been given this data called collision, of type collision from somewhere else. And Unity was the one doing the, Unity's physics system is the one figuring out what all that data is and telling us that it happened. So now, if we look in our game, I hit the floor, and it tells me the name. It tells me what I hit. I hit floor, and if I keep moving, I can see that I hit cube, I hit floor, I hit the coin visuals, I hit floor 3, I hit floor 2. Very nice. So now I can use this to figure out what I hit. And if I hit a coin, haha, I can collect the coin. Very good. So I need a way to figure out if the thing I hit is a coin. Well, one, my coin is named coin, but we notice it's not actually named coin. It's named cube. Well, it's not named cube. It's named, let me hit play, and we have our coins that exist. It's named coin parentheses clone. So I could check if the thing I hit, if other.gameObject.name is equal to coin clone. I have an event. Clone. Don't do this. That's a terrible system. It's awful. Because you will rename things, and you must be able to freely rename your objects. You must be able to change your naming convention, change your prefab to be like C_coin or prefab_coin, so that it's, as your project gets really large, it's easier to find your things that you're looking for or whatever. And you don't want that to break your code, so you never want to do this. Instead, oh, think back. Remember, earlier we were talking about tags. Brilliant. We're going to use a tag to identify what things are a coin, right? Then I can have a 5 coin value coin and a 10 value coin and a 100 value coin. But I don't have a coin tag. So I need to add a tag. I could click this button, which brings up this thing in the inspector, and it brings up a little list to add it to. But I want to show you how to get here the other way to show you what this menu is. You go to your Edit, Project Settings, and we find our Tags and Layers setting, and look at that, it's the same menu. So Edit, Project Settings, Tags and Layers, and we can find our tags, and we can add a tag called coin. And you're good to go. I'm going to delete that for a second, just to demonstrate something, a very common Unity mistake, which is when I go down here and I click Add Tag, all that does is open the menu. If I now go in and add the tag and hit Save, you might reasonably believe that Unity has added that tag to the game object. You would be wrong. All that little shorthand add tag thing did was open the menu. In the menu, you created the tag. Now we can add it, but it didn't assign it to the variable. So now we got to go back to the coin spawner, select it, and choose tag. No, we don't. We got to go back to the prefab, the coin prefab, and select tag. Except we're not actually colliding with the coin. We're colliding with this child object of the coin. So for now, I'm just going to make that tagged coin, right? If I only change the parent object, well, the thing I hit was this capsule collider, and its game object is this child game object, and its tag would be untagged. So we'll change this one to coin 2. And now we hit play. And I have to restart my thing because of my stupid little bug with my little thing. Okay. Boom. And I hit coin visuals. Great. I didn't actually change any other code, did I? Because this thing was in here. Okay. Next, we can get the tag property of the game object with .tag, and we can see if it is equal to coin. Don't do that. Don't do that. Instead, we're going to use a function called compareTag, and we're going to give it coin. Yeah, it looks the same, but it's different. And the reason this one is different is because it optimized behind the scenes. It optimizes these strings into integers, into little bits, and it compares two numbers. And computers are very, very efficient at comparing two numbers. Comparing two strings, doing it this way, loops through every single character and looks until it finds a difference in them. And it's like hundreds of times faster to run this function than it is to do string comparisons. Will that affect your code and your game's performance? No. Do it because I said so? Yes. Okay, so if the thing we hit is the coin, we will destroy the thing that we hit. And let's see if we can destroy any coins. Destroy is a function. We can give it any object or component to destroy. We're going to give it the game object of the thing that we hit. Don't type this. That'll destroy the player's game object. We want the other thing's game object. Okay. No. I should just fix that. Okay. And I hope you saw it. The little coins disappeared. Brilliant. Now we have a variable. We call it score. We increase our score and we get a coin. Bing, bang, boom. We're done. Except my coin hit my player hit the coin and then bounced off of the coin, and then the coin went away. And that's because a collision actually happened. We didn't just go through it invisibly. First, let me change my camera follow to be the actual follow target script. I want to follow the player. Just to make life easier. So let's take a look at how what's actually happening here a little bit better. So I knock into that coin. I don't want to do that. Instead, we're going to change a property about the coins, about the collider. And we're going to change it from a collider, which defines a shape and says this is solid, to a trigger, which defines a shape in the physics system, but does not enforce that it is solid. It will use events in the event system, but it can be ignored. You can hover over, you can I'm reading this text. If we can use events to detect when the player has entered and exited this region, this shape that the collider component defines, but we don't actually, hit it, which is good. So if I make that a trigger, just with the checkbox, collider shapes. Triggers are very different in the physics system, but they're shapes, and it's just a checkbox in our collider component. All of our collider components have that checkbox, a box collider or whatever, sphere, anything. If we go in, we should now be able to go through the coins. But I am no longer collecting them. And that's because I don't need the onCollision event anymore. I want the onTrigger event now. And we're just going to copy this code. I'm going to paste it there. So it doesn't use a collider, a collision property, right? I can't just change the name of this one. It uses a different data type in its property. It uses a collider, the base class for all the colliders. It just gives you a reference to the component of the thing that you hit. It's just going to give us a reference to this component object. But that's fine because we can get the game object reference and we can get the tag right from that. So that's fine. So let's take this code. Let's comment it out. Leaving some zombie code behind, generally a bad practice. I recommend you just delete it. Once you know you don't need it anymore, you should just delete it. Don't leave it there. You don't need to reference it later. You can figure it out again. But let's see if changing our trigger event to that onTriggerEnter function is going to be, if I cannot die, hey, there we go. I collected the coin and I did not lose my momentum. Brilliant. So we use trigger zones all the time. We use trigger zones to the player in this game maybe goes over a finish line. I make a big collider shape, call it finish line, give it a tag called finish line, make it a trigger, and then player, when they hit the finish line, we're done. And the game is over. So using instantiating objects, you can create objects that have velocities that move themselves in a direction. They do things like add a force on start, and we give that to a bullet script. And then on the player, we, check if we push a button, like we get the space button down, and we hit that and we move, all sorts of things. And that's sort of the logic of how we're going to be making mechanics. So your next assignment will be to make an actual mechanic, but more information about that and how to go about it will be written out. So think about what type of game you might want to make, and we're just going to make one little piece of it. And with physics and physics events as kind of our tool to hook us into like actual logic and behaviors of like how games work. We're going to refactor and clean this code up in the next intro video, but I don't know, I'm like 8 minutes over on time. Probably because I talked about Quaternions. So we're going to end it here. See you next time. Good luck on the assignment. There are some more videos that will be relevant to completing those around and about and linked on this intro page. So goodbye.